Hello everyone, this is Amir Sharif. I'm VP of Product and Marketing here at Opsani. I'm here with Blake Waters. Blake, nice to have you here for our webinar.
Thanks for having me.
Can you tell the world what you do for Opsani?
Yeah, absolutely. So I lead the customer engineering group where we're focused on kind of doing the last mile rollout of our Opsani's continuous optimization technology to customer environments. So we have to identify what systems they have in place for controlling their metrics and kind of managing their infrastructure and doing that configuration and integration and to enable them to be able to utilize our technology.
Is that necessary in every case or in the more complex cases?
So it really kind of runs the gamut. Some of our integrations are pretty straightforward with off the shelf kind of modern technologies like Prometheus or Kubernetes. Some of our customers have legacy systems that predate the cloud era, and they might require a lot of kind of custom integration.
So the older systems require more curation, if you would, more integration.
Yeah, they tend to be kind of special snowflakes where they might have been developed internally, predating the cloud and kind of like repeatable orchestration technologies, and those are necessarily require some custom integration.
And they're now moving to the cloud, and we're helping optimize those workloads.
Yes.
So I'd like to for you to tell the audience a little bit about your background, because as we've talked, you've had this very interesting career that predates the cloud, and that's giving you a lot of insight into how things have changed. So can you expand on that a little bit?
Yeah, absolutely. So I started my career in the early 2000s and kind of we were still racking and stacking machines and kind of working on a colo facilities. It was all data centers and kind of going in, you're scanning your handprint, you're going and plugging devices in, and you had to figure out how many servers you need to order from Dell or HP or whatever, and install them and kind of take them out there. And then mid 2000s, the AWS kind of rises, and you're able to start procuring machines on more of a kind of service basis. And then we kind of had the third shift to embracing kind of cloud native, where you don't even need to think about the hardware resources themselves. You can just say, like, I need this much compute, this much memory, and kind of dynamically allocate it.
So clearly a shift from a CapEx model where you bought everything up front to a virtualized version of that world, which AWS started selling as a service, to a much more dynamic of API-oriented infrastructure, invisible computing infrastructure, right?
Yeah, we've gone through buying physical machines to being able to procure abstractions of physical machines via APIs, to now not even thinking about those things and just thinking about the workloads we want to run and deploying them. And I don't care how many computers there are or what the networking interfaces are, I just want this application to run.
And you also have had some roles in development, and I know that you code, so you have insight on how development has changed over that time.
Yeah, absolutely. I mean, it's when I started my career, we were still very much in the waterfall world, where you would do a big phase of design and defining what the product was going to be. Then go into a phase of development, kind of implementing it. Then quality assurance and testing, then optimization, and then release. And you might go through 3 to 5 releases a year. For large applications and enterprise things, it might be once a year.
Okay, and now that model has changed into a much more rapid CI/CD oriented pipeline, where some places like Amazon, they measure multiple times a second.
Yeah, absolutely. We've started to build much more complex applications. We want to deliver them fast. We've embraced the idea that you can't actually figure things out in that design phase, and that you need to do more experiments. So you need to be able to continuously release things and kind of adapt to change very rapidly. And that has given rise to continuous integration and testing, because you still want it to know that it works. And then continuous deployment, like if the test pass and the commit lands, like just ship it and get it out there. and you can even put new features behind like A/B testing frameworks, and you might have multiple versions of your product kind of live simultaneously.
What's the business driver for going into a more rapid delivery model?
You want to. We want to be able to build, bigger, more complex and integrated products, and you wanted to. It can be a competitive advantage for if the products are optimized or perform better versus other products in the market, and that can ultimately lead to more attractive margins if you're trying to raise capital, or having better financials if you're publicly traded.
Okay, so rapidity of code delivery I gather is also part of that, but how quickly you deliver features.
Yeah, absolutely. The faster that you can roll things out, the more competitive you can be. And if you're having to discover what features and what consumers actually want, that signal to noise ratio, the faster that your feedback loop is, the better the product is, and that can ultimately let you win in a competitive market.
Okay, so now the picture is becoming clear. The infrastructure became more fungible and more API oriented. The delivery has taken similar characteristics, whereas it went from a rigid waterfall model with optimization being part of it to a much more rapid component of it. Mm-hmm. Has optimization kept up with those two artifact changes, both on the infrastructure side and code delivery side?
No, and that's one of the things that I found so fascinating about Opsani. We just kind of stopped doing optimization. It just kind of dropped out. Like we're trying to move so fast and build such complex products that we just kind of stopped doing it. And now that we can allocate resources on an API basis and don't have to really think about it up front, it enables us to just over provision, and we have larger teams. So there might be multiple groups of people that are all allocating resources, and your expenditure is the aggregate sum of all of those decisions, but nobody's kind of sees all the pieces that are being decided.
Just for clarification, basically you're saying that because the speed at which software is getting developed and hardware itself has gotten more powerful, you could not do the optimization step and still show decent results, because hardware being juiced up provided mask for your sloppiness in the delivery side.
Yeah, totally. I mean, nobody wants to get woken up in the middle of the night because of pager duty going off. We have SLAs that we're guaranteeing our customers that we need to meet, and everybody can just kind of put their finger in the air and say, I think I need this much, and then their manager says, okay, let's add another 30% on top of it, and you do that over a giant group of teams and over a number of years, and it adds up to a ton of kind of wasted resources.
So enter Opsani. Talk about Opsani continuous optimization. How does that complement the movement to the cloud from the infrastructure side and the continuous delivery, continuous integration aspects of it?
Yeah, so Opsani's continuous optimization technology is able to take a very large number of variables into account, from things like the instance type, the amount of memory, the amount of compute resources, buffers, caches, individual settings on JVM runtime environments, and systematically explore all of those and figure out what the optimal set of configurations are for your application at one particular moment in time. And it can do that on an ongoing basis, where a new release kind of comes out, a new developer pushes another commit, and you go through, and the models will go back through that same process and figure out what the actual optimal set of resources and configuration necessary for your application at this moment in time. And that might be radically different from a month ago, a week ago, or even 2 hours ago, depending on what's going on with your team.
Yeah, so why does that change? Why is a continuous aspect of continuous optimization important? You mentioned that things can change radically from one day to the next. What causes that change?
It's just the complexity and the size of teams. we're building more ambitious, bigger products that span a much wider surface area. We have a lot more developers kind of operating in parallel. We've things like continuous integration and continuous deployment and containers and service-oriented architectures have allowed us to break things up and operate independently with kind of loosely coupled pieces, but that expands the amount of complexity, and all of those decisions are happening in parallel. So there's no longer this kind of aggregate view of how that all kind of adds up.
Okay, so I'm now in the cloud. I have CI/CD. Therefore, I have sort of on-demand infrastructure that allows me to not consume costs theoretically, but to have CI/CD, which allows me to deliver code faster. And you talked about more ambitious projects with bigger people, but therefore I'm likely to consume more resources, and that creates a business problem for me. That business problem is just more than necessary expenditures. So you also talked about why it's too complex for people because of the number of variables. How does Opsani solve the problem where people fail?
Yeah, so we have machine learning models that can take in all of those different variables and systematically explore that problem space, remembering what a particular change in setting impacts in terms of performance and cost, and allow you to define whether you want to have the highest performance with the lowest amount of spend, or spend the lowest amount of money possible to support your SLAs, or achieve some kind of balance between those. And in order to understand that, it requires a ridiculous number of explorations of that problem space.
Yeah, I've heard Peter, our CTO and co-founder, talk about taking trillions of permutations if it were to be done by brute force, whereas machine learning converges on a solution pretty quickly.
Yeah, it's not possible for a human to go through all of those things. I mean, some of our customer implementations, they'll run for days or weeks in order to understand all the different variables in play and arrive at the optimal solution.
As I recall, you had a leadership role before coming to Opsani at another company. Can you talk about what you did for optimization at that company?
Yeah, absolutely. So I was a CTO at a company called Layer, where we built a developer-facing messaging and chat platform supporting thousands of applications and tens of millions of monthly active users. And we were spending hundreds of thousands a month on Google Cloud spend. And once a month, me and like 5 of the senior engineering leaders would get around a conference table just like this and look at our invoices and can we change this instance type? Or do we really need that many hard drives? And we would kind of negotiate against ourselves, trying to figure out how to reduce the amount of money that we're spending without violating our SLAs or getting woken up in the middle of the night. But it was totally unscientific and ad hoc. It was kind of like, do you think we can get away with this?
And would Opsani have helped you in the previous job?
Oh, 100%.
And so you would have been your own customer, basically.
Yeah, definitely. And in a competitive market, if we had this technology, it might have allowed us to have better margins and run more efficiently versus the competition.
So, talk about why we matter from a business perspective to the customers that you're engaged with. You're engaged in practically every customer that we have. Why is it that what's their business driver for purchasing Opsani?
So there's kind of two main things. One, in any kind of competitive market, or especially in a consumer-facing application, the better the user experience, the more performant it is. The more delighted the customers are, the higher the NPS you're going to have, and the better the application is going to be. So that's kind of on the experience delivery side. There's also cost and margins. Like, nobody wants to light money on fire. You're getting judged by your investors or the market in terms of what your margins are. So being more efficient to deliver that same experience is valuable.
So the argument is delivering the experience that differentiates your product, and delivering at a cost that's low enough that differentiates you from the competition.
Yep, 100%.
Very well.
And there's there are diminishing returns. Like you can't just if you just keep throwing resources at something, you will hit a point of diminishing returns where it's not necessarily going to deliver a better experience. But knowing where that breaking point is could be the difference.
Differentiating yourself from competition, it reminds me of a conversation I had in 2004, 2005, where Google was still at that point an upstart, and Yahoo was a dominant search engine at the time.
Yep.
And there was a big distance between the two. And Google was spending considerable amount of resources optimizing their hardware resources. By that I mean making sure that everything was DC, there was no AC to DC conversion, and even within DC that everything had the same voltage. So they were rather pedantic in making sure that all the components had the same voltage and there was no step up or step down functions that would generate heat. As a result, the servers ran a lot more efficiently and Google could spend less on HVAC, cooling down their data centers, and that meant savings. At a time that seemed pretty esoteric because what Yahoo did was just go buy off-the-shelf hardware from somewhere and then they would just air condition the heck out of their data centers. But Google's argument 15 years ago was because their OpEx is less, they can invest the money in becoming more competitive and they can invest it on the places where it mattered for the customer, which is the search experience. Fast forward 15 years, they seem to have been right. Do you think the same parallels hold for our customers?
Yeah, 100%. I mean, scale changes everything. I mean, even if you're talking about a 3 to 5% efficiency gain, but spanning that over a multi-billion-dollar industry, let alone that you can identify 20 to 30% savings. That adds up to real money.
So 20 to 30% savings. So without giving specific numbers, what are roughly the types of orders of magnitude? What sort of savings do you see our customers having?
Without saying too much, we've seen high 20s to mid 30s savings for a lot of our implementations, and for some of them even higher than that.
So if I am spending $10 million a year on a particular application, maintaining it, and that's not out of the world, like for a large scale SaaS application, then I'm saving $2 to $3 million a year.
Yeah.
That's after spending on upselling.
Yep.
Very well. That's pretty compelling business.
Yeah, and it's kind of like if you're spending $1 million you don't need to with Amazon, you keep 800K and you give us 200 and we'll call it a day.
So looking forward, what are some of the key challenges that you see for the market and how can Opsani address those?
So I think the first thing is just awareness that optimization is really a thing, because the new generation of engineers haven't even lived through a world where they were doing it. So we need to remember that this is actually a problem, and then address the gaps in the tools and the workflows to bring it back in and make it part of ongoing engineering practices.
And then Opsani just helps automate that.
Yes.
Practically.
Yep.
That actually rings true, because I remember when I was an engineer, one of the things I used to do, I spent an inordinate number of time reducing the number of lines of instruction that I had in order to get the same results. So if I could go from 100 lines down to 24 to get the same thing, it was a big win because it was optimization.
Yep, totally. And Moore's law has kind of spoiled us a little bit. Like I had a whole period in my career where I was working on mobile applications in the early days of the App Store, and the phones were ridiculously underpowered and slow. And you'd spend a ton of time in Xcode and profiling and optimizing to be able to get a high frame rate and a good slick experience. But now the things are so fast that people are starting to do it anymore.
Except now computation is an OpEx. Yeah. It's a continuously charged thing. So if you're running inefficiently, it's going to come behind you.
Yeah, and if you're in a competitive market and the competition pays attention to this and you don't, they're gonna have better margins, a better user experience, and they're gonna win.
Well, Blake, thank you so much for teaching us a little bit about what you do and about the challenges that the customers are facing. And thanks everyone. With that, we're going to go to Q&A and see what the questions we can answer.
Looking forward to it.
All right, so questions are coming in, and good morning, Blake. Yeah, for given the sign of modern times, Blake and I had to be sequestered separately. So I'm literally holed up in my bunker, as you can see from the background. And I can assure everyone in the world that Blake and I are at least 6 feet away.
Yep, that is definitely true.
So questions are coming in, and the first question from the panel, from the audience, is that we mentioned optimization casually throughout, or I guess we, I mean you. Can you being the collective us, can you provide a clear and concise definition of what optimization in the cloud means?
Yeah, sure. So, put simply, optimization is the practice of identifying the most efficient configurations for operating an application through data-driven exploration and verification of those settings. It's a repeatable methodology that's designed to come out with a correct answer more than kind of tweaking. So these kind of settings could range from very low-level details, such as what CPU architecture you're running on, how many cores are allocated, how much memory, those kind of things, all the way up to things that are very application and infrastructure specific, such as what feature flags are even enabled for the application side. When you think about optimization in the context of the cloud, optimizable settings become things like the instance type that you're allocating from your cloud provider, resource allocations through an orchestrator like Kubernetes, or API-driven configurations of the managed services that you might be building your application on top of. Does that make sense?
Makes perfect sense. And if more questions come out on this front, I'll bring them up. Now we have a follow-up question. It says, you mentioned that the creation of CI/CD optimization kind of just fell off.
Mm-hmm.
Can you dig into that a little bit more and discuss why it fell off? If optimization is really impactful, wouldn't it still be something that companies would try to do and often keep it within their processes?
Yeah, so there's a little bit of tea leaf reading here, but I can certainly kind of share my perspective on it. I think ultimately software engineering is a discipline that's delivered and built around repeatable patterns and tooling. That's what enables us to hire up and scale teams, train people up, and then continue to deliver as quickly as possible. So because of those constraints around how we're actually able to organize teams of engineers, we become a little bit beholden to the tools and processes that we have at our disposal. So what's happened is that as the business drivers have pushed us to need to deliver things at as quickly as possible, build with bigger teams, and kind of in order to build a sustainable business advantage, whoever's able to get things to market faster, iterate in response to feedback more quickly tends to win. That overriding pressure has pushed us to deliver things ahead of where the tooling and processes to support optimization are, and so they've just kind of dropped out of our workflow a little bit. There's been some other macro trends like the commoditization of hardware and resources, pay-as-you-go pricing that allows us to prop up the performance to meet our objectives by throwing more resources at it, which has kind of papered over some of the imperatives that used to drive optimization. We think that this is really points to a fundamental gap in the tooling and processes and workflow, and that once teams and engineers are armed with modern tools that can keep up with the speed of business and integrate with their workflows and support speed and efficiency, that optimization will come back in a big way because it offers a ton of advantages and new competitive edges.
Makes perfect sense. So if I could rephrase what you said, basically, it's because we could hide lack of optimization due to a number of different factors, it was convenient to let it fall off. That also was compounded with the complexity of the projects. But now, because it can be automated using ML, and as such can afford competitive advantages, we anticipate coming back in a big way.
Yeah, and I think, and a key part of that is integrating it with the workflows that we've embraced, and that's continuous, integration, verifying that the test pass, that things work, continuous deployment and delivery, and then we kind of see, once you're getting ready to deploy those that new code, having it identify the optimal configuration and then deploying it right-sized on the set of resources to match your objectives, the reality of where your traffic is, and the change that you're introducing into your system. That's really the next step of where this workflow all goes.
Very well. And another question has come in, and this one's, I think the way it's phrased, it's from a DevOps engineer.
Mm-hmm.
It says, where does optimization, or I guess where does continuous optimization fit into my CI/CD pipeline? So I guess they're teeing off that there's continuous optimization, therefore there's CI/CD and CO.
Yeah, so there's a couple of different logical places depending on kind of the maturity model of where you are in kind of the CI and kind of CD continuum. The most sophisticated Sonic customers who have really gone all in on continuous delivery are typically deploying, multiple times a day. You may have multiple teams that are pushing in, deploying different services onto a common cluster of shared infrastructure. And they tend to embrace utilizing canary-based deployments, where we might be splitting off a portion of production traffic that's representative of the overall set of traffic that you're handling, allowing the Opsani CO engine to perform optimization within that fractional piece of the overall traffic, identify what the optimal configuration for that infrastructure application settings, and then automatically promote that cluster wide once it's finished doing the identifying what the optimal is. So that's kind of the nirvana where everybody will eventually get to, but you don't have to be kind of all the way there in order to unlock the benefits of optimization. Customers that might be still on train-based delivery models where there's a schedule that it leaves every 2 weeks, or even more kind of ad hoc deployments that are done on, an engineer decides that it's time to hit release and runs the release scripts. There you might have a discrete phase where you're saying, okay, we're code complete, we're going to perform an optimization run and set up our configuration through an infrastructure as code tool like a Terraform or something like that, using the output of the CO engine to identify what those settings are, and then deploying those along with your application code into the infrastructure in kind of a big bang release. Part of what my team does is works with our customers and prospects to identify kind of where they're at, what their goals are, and where they're trying to, what they're trying to get out of optimization over what kind of timeline. Look at what their tooling CI and CD pipeline looks like, and identify what the optimal place is to introduce CO into that pipeline, and then think about where you want to get to, next week, next month, next quarter, next year, and continue to evolve that as you kind of your team grows and you move along the maturity model.
Very well, and there are more questions that are coming in, but we've run over our allotted time, and I'm getting this signal from the producer, so I think we're going to leave it at that. And Blake, I hope you and your family and everyone out there stays healthy. These are different times, but it's certainly a good time to take stock of what we do and get to do them better. And hopefully we'll all come out of this healthy and happy and in better shape and more optimized. All right. All right, Blake, you hopefully in person sometime soon.
Hopefully.
All right, bye-bye.